Welcome to Math with Father. Welcome to Math with Father. Subscribe, like and share.
In today's video, we are going to talk about equations pertaining indices. And there are equations which have variables or unknown quantity as an index. Example, b to the power x equals b to the power y. So this equation has index or powers as an unknown variable, and these are called the exponentials or exponential equation. So we have three basic types. So now let's begin with the linear equation. So every linear equation is of the form. Now the highest index or power of every linear equation is 1. So with this, we are going to come out with an index form, something of this sort. B to the power x equals b to the power y. Index equation, we have b as our base. We have b as our base. And then it states that if the bases are the same, the powers are equated. So we have b, we have another b. So we have b, which is also similar or the same thing as this b. So if they are the same, we equate the powers. Now we have x equals y. And this is a linear equation. So we are going to resolve some questions in this form, or we are going to look at questions in this form. Okay, so if 3 to the power x is equal to 3 to the power 2, here we are to find x. So this is an equation, and where is this equation leading us? Now with the linear, it says if the bases are the same, the powers are equated. So we have x equals 2, and this gives us our value for x. Now take a book and then try to find the value of x in 30 seconds. Guess what? I know 90% of the class was able to do this. Now, similar to what we just did, so we have 4 as our base, we have another 4 as our base, and since they are the same, the powers are equated. So we have x equals -3, and this is our value of x. Now we are going to look at some illustrative examples. Okay, all right, so now let's solve for the value of x from these following equations. Looking at our first equation, which is 3 to the power x equals 9. 3 to the power x equals 9. So with this case, we are going to change the expression to suit. We are going to change the expression to suit one certain base, and the smaller value here is 3. So we are going to change this value 9 into an index form that has 3 as its base. Now we have 3x equals 9 could or can be written as 3 to the power 2. So this is the simplified form or the index form of this. And now since the bases are the same, the exponents are equated, and our value x is 2. Our value x is now 2. So this is from the first one. So we have x to be 2. Let's move on to the second one, which is 9 to the power 4x equals 81. 9 to the power 4x equals 81. So looking at this equation, the smaller base that we have here is 9, and 81 could also be changed to the same base. So the simplified form of this equation, 9 raised to the power 4x equals, so we are changing 81 to suit this base, and what number to a power gives us 89? So we should change it to, so 9 raised to the power 2 also gives 89, and from the condition that if the bases are the same, the exponents are equated. So we have 4x is equal to 2. Now we want the value of x. So what do? We multiply both sides by the inverse of 4, which is 1 on 4, the multiplicative inverse. Now 4 into itself, 4 into itself, 4 into itself 1, 2 into itself 1, 2 into 4 2, and then our value x is equal to 1. 1 times 1 is giving us 1, all on 2. Now this is our value of x from this equation. Let's move on to the next question. So we have 4 raised to the power negative 3x equals 1 on 64. So how do we find the unknown, which is x? 4 raised to the power negative 3x equals 1 on 64. So let's solve this. Now the smaller, so this is also an index form, and we have to also change this to an index form to have a base of 4. Now we have 4 to the power negative 3x equals, so this, if you would remember from the properties, this is a negative index. So it says for the negative index, 1 on a is written as a to the power negative 1. So we're also going to write this fraction to this linear form, so to carry an index or a power. So this is also written as 64 raised to the power negative 1. Now 4 raised to the power negative 3x equals, now we change 64 to a base of 4, and then we have 4 raised to the power 3 gives us 64 multiplied by this index or power negative 1. Now 4 raised to the power negative 3x equals 4 raised to the power, so we have 3 multiplying negative 1, which yields negative 3. 4 raised to the power negative 3x equals 4 raised to the power negative 3. So let's go back and check. 4 raised to the power negative 3x equals 4 raised to the power negative 3. Okay. Now our bases are the same. So from this point, we have 4 as our base, we have 4 as our base. And the condition says if the bases are the same, the powers are equated. Negative 3x equals negative 3. And finding the value of x, negative 3, negative 3. And then x gives us 1. So 1 is our value of x. And this is the solution set for the third question, for this question, for this question. So we started here, and then arrived at this point. So we are moving on to the fourth question, so which is 2 raised to the power square root of x equals 8x. 2 raised to the power root x equals 8x. So we are going to simplify this equation to have the same base. To resolve, we are going to resolve this to similar base. Now we have 2 raised to the power root x equals, so the smaller number here is 2, meaning we have to change 8 to also get a base or 2 as its base. And we have 2 raised to the power 3, which is 8, multiplying the power x. And the condition states that if the base, so we have 2 as a base, we have another 2, then we equate the powers, which is root x equals 3x, multiplying 3 by x. That is the third law, the power law. Now square root of x is equal to 3x, and if you would remember from the fractional index that square root means half, so we have square root of x is the same thing as x to the power half. So at this point, I'm going to get rid of the root. I have x raised to the power 1 on 2 is equal to 3x. So to find the value of x, what I'm going to do here is I'm going to neutralize this part, which is half. So to neutralize this, I have to multiply the power by 2. So by 2, and then I do same here. This is also multiplied or raised to the power 2. So we have 2, getting rid of 2, and we have x. So we have x raised to the power 1, which is the same thing as x, equals, we have 2 multiplying 3 giving us 9, and then we have 2 also multiplying x raised giving us x squared. So we have x equals 9x squared. So this is leading us to a quadratic equation, meaning we're getting 2x values. Let's proceed. Now we have x minus equals 9x squared. So let's go back and then validate. X equals 9x squared. X equals 9x squared. Thank you. So how do we find the value of x? 9. So here I'm taking this x to the other side. I have 9x squared minus x equals 0. And resolving this, we have a common thing. X, we have x. So x could be factored out or can be factored out. And what we have inside, we have 9x minus 1 is equal to 0. So we have x equals to 0 as one of the answers. X equals 0. And we also have 9x minus 1 equals to 0. So 9x minus 1 equals to 0. Now let's find x. 9x is equal to, this one is taken to this side. And if a negative number crosses an equal sign, it changes to be positive. So we have plus 1. 9x equals to 1. And we try to make x the subject. We have divided by 9, divided by 9. And our variable x gives us 1 on 9. So these are the two x values. So therefore, x is equal to 0 or 1 on 9. So x is equal to 0 or 1 on 9. So these are the two x values from this equation. These are the two x values from this equation. From this equation. So we are moving on to the last question, which is 125 raised to the power x minus 3 equals the square root of 5 raised to the power 4x minus 7. We are going to find the value x. 125 raised to the power x minus 3 equals all under square root 5 raised to the power 4 x minus 3. So let's start. So with what we have over here, we are going to resolve this into the smaller or the smallest base, and we have 5 as a base, we have 125 as a base. So comparing these two bases, the 5 is the smallest or the smaller base, meaning we have to change 125 to a base of 5. 125 x minus 3 equals all under square root. So 125, which is 125 is equal to 5 times 5 times 5. 5 times 5 gives us 25, and then 25 times 5 gives us 125. So how many of the 5s? We have 1, 2, 3. 3 of the 5. So 1 is taken, and the number of times is written on top, which is 3 times. Multiplying x minus 3 equals the square root of 5 raised to the power 4x minus 3. Alright, so we have the same expression or the same equation. The 3 is multiplied from the expression, or is multiplied with the expression inside the bracket. So we have 3 multiplying x, then we have 3x, we have 3 also multiplying negative 3, it gives us negative 9, equals, now we also know that square root means to the power half. So we are going to express this root or this symbol or this sign into this form. We have 5 to the power 4 x minus 3. So all raised to the power half. Now 5 is equal to 5. We have 4x by 4x times 1 on 2 minus 3 times 1 on 2. So the 1 on 2 is the power. So this by this by this. So which is done nicely over here. Now we have 5 to the power 3x minus 9 equals 5 raised to the power. So here we have a common thing to cancel out. 2 into itself 1, 2 into 4 2. Now we have 2 multiplying x, which yields 2x minus, so 3 times half gives us 3 on 2. And since the bases from this equation are the same, their exponents or index or power is equated. So we have 3x minus 9, 3x minus 9 equals 2x minus 3 on 2. 2x minus 3 on 2. So at this point, we group, or we are going to group like terms. So in grouping like terms, we have 3x. We also have another x, which is 2x. So we have to now send it to this side, and then crossing the equal sign, change this to negative 2x equals negative 3 on 2. The 9 is also negative 9 is taken to this side. We have 9. Now 3x minus 2x is given as x equals, we have a fraction which is negative 3 on 2 plus 9. Any whole number is divided by 1. So this is also the fraction form of this. Now we find the LCM to our fraction, and the LCM is 2. So 2 into itself 1 times negative 3, 2, 1 into 2, 2 by 9, which gives us 18. And then our result is 15 on 2. So we have x to be 15 on 2. So this is also our value of x from this equation. From this equation, this is our value of x from this equation. Okay, so this is all about the linear equation. This is all about the linear equation. So with the linear equation, the exponential equations will be given to you, and after coming out with a common base, the powers are equated in a linear form. The powers are, so after coming out with a common base, the powers are equated, and the variable that you are asked to find for is now dealt with. Now we move on to the second equation, quadratic equation. So exponential equations, which leads us to quadratic equations. How do we solve these kinds? So our next section, we will be moving on to quadratic equations. So similar to how we started with the linear equation, so now we have b raised to the power 2x equals b to the power y. And so from the power law, it states that anytime we encounter this exponential or this index from a raised to the power x all raised to the all multiplying y. This is also written as a raised to the power x times y, x multiplying y, and this gives us a xy. So looking at this condition, the b raised to the power 2x is also, it also has a power multiplying another power, so it is 2 multiplying x, similar to this one. So we're also resolving it this way. So this could also be rewritten as b raised to the power x all multiplied by 2 equals b to the power y. So with the condition, it states that if the base are the same, so we have b as a base, we have another b as a base, so this could be rewritten as x squared equals y. And any equation that has its highest index as 2 or the highest power as 2 is called a quadratic equation. So quadratic equations are of the form a x squared plus bx plus c is equal to 0. So this is the general quadratic equation. So meaning at the end, after coming out with a common base and then equating the powers should look similar to this kind of equation. So to obtain the solution of the exponential equation, 2 raised to the power 2x minus 5 multiplying 2 to the power x plus 4 equals to 0. So this is an exponential equation. And how do we solve this? So solution. From the first term, we have 2 raised to the power 2x. So this obeys the power law. Minus 5 raised to the 5 multiplying 2 raised to the power x plus 4 equals 0. So what we are going to do is we are going to change or make each term have a similar base. We are going to resolve this to get a similar base for all the terms. Anytime we encounter this a raised to the power x all multiplied by y, this is also written as a raised to the power x by y, and the simplified form of this is axy. So our first term, which is 2 to the power xy, also looks similar to this. So we have 2 as our a, we have or y, and then we have to the power 2 or x as our x. So we are going to resolve it to suit this, something of this sort. Now, the clue is every question comes with a clue, and the clue is there will be a specific base given which should suit each term. So each term should bear that base. And then per this question, the unique base is 2 to the power x. So now we are going to resolve this to also suit this one, and then resolve this to also have or bear the same base. Now 2 to the power x. So since this is the unique base, this with or in the power, using the power law, is written as 2 to the power x multiplied or raised to the power 2. So I've resolved this into to this. So I have 2x raised to the power 2 minus 5 multiplying 2 raised to the power x plus 4 equals 0. Okay, so comparing this to the general equation, which is comparing this to the general equation, which is a x squared plus bx plus c equals 0. Now we have 2 to the power x raised to the power 2. So looking at this, we have to the power 2, we have x, which is to the power 1, we have to the power 1, and then we have a constant thing, which is our c. So what we are going to do here is we are going to set the unique index form, which is 2x. So 2x, we have 2x, and then we have a 2x here, but students at times confuse themselves with it. And the truth of the matter is, looking at this, the first index of 2 to the power x is 2. The second index of 2 to the power x is 1. So what will be the last index of 2 to the power x? That will be 0. So this can be written this way: 2 to the power x raised to the power 2 minus 5 raised to the multiplying 2 to the power x by 1 plus 4 multiplying 2 to the power x 0. 0 is equal to 0. So we can all see that the power decreases as we move to our right hand side. So here the first power is 2, the second power is 1, the third power is 0. And from the 0 index, it says any number raised to the power 0 is 1. So 2x to the power 0 is 1, and 1 times 4 gives us 4. So that is why this is not written, but this is the notion behind the constant thing. So we have 2 to the power x as an index, 2 to the power x as an index, 2 to the power x as an index. So looking at the terms, it sails or cuts across. So now what we are going to do next is we are going to set the common index form, which is 2 to the power x, to an unknown. And here, since x was used in the question, we will set it to a different unknown. So now let's y be equal to 2 to the power x. We substitute y inside our equation. So anywhere we see 2 to the power x, we replace it with y. So the first one, we have y, which is this 2x raised to the power 2 minus 5 multiplying y plus 4 equals 0. So this leads us to our proper. So we are going to resolve the value for y. We are going to resolve the value for y. So what we are going to do is we are going to break this into two factors, and with this we have several or numerous ways of solving this. So we can go use the quadratic form to find for the value y. We can also use the factor form. So let's use the factor form. So with the factor form, what we are going to do is we are going to multiply the coefficients, or we are going to find the product, and then we're also going to find the sum. So the product of roots and then the sum of roots. So with the product, we are going to multiply the coefficient of y squared, which is 1, by the coefficient of, or for the constant. We are going to multiply the coefficient of y squared, which is 1, by the constant term, which is 4. And the result is 4. So from this product, which is given us 4, we are going to find two factors from this product. When summed up, would be given us 5. And then from the factors of 4, so here we would be using negative or positive. We have negative 4, negative 1. Negative 4 times negative 1. Negative 4 times negative 1 gives us 4. Negative 4 plus negative 1 also gives us negative 5. So when multiplied, we should get 4, but when summed up, we should get negative 5. Now we have y squared minus, so with the sum, which is negative 5y, we are going to replace it with the summation of these two factors. The summation of these two factors, 4, and since so y, negative y is our 1, negative 1y, and 1 multiplied by anything gives us the same thing, so which is negative y minus 4y plus 4 equals 0. Now we have y squared as our y, we have negative 5y as negative y, negative 4y, so summing up these two gives us back negative 5y plus 4, we have plus 4 equals 0. So we are going to group this into factors. Now I have y squared minus y into brackets, or plus negative 4y plus 4 is equal to 0. So at this point, what most of the students do is, in the grouping, they make this petty mistake, and then it costs them really much. So in grouping these terms, in grouping these expression or these terms, what I have noticed in class is, anytime we have y squared, or anytime we have this quadratic equation, what most of the students do is, they make, in the grouping, they do make mistakes when grouping. So they do it this way: y squared minus y minus 4y plus 4 is equal to 0. So anytime you factor the operation sign when grouping the other two terms, we do it this way. This is the wrong thing, because when you try to now simplify it this way, you are not still going to get back this. We have y squared minus y minus by 4y, negative 4y. We have minus by positive 4, giving us negative 4 is equal to 0. And this is not the same thing as this. We have y squared minus y minus 4y minus 4y. See here, with the constant term, the original equation was positive 4 or plus 4, and after simplifying this, you are getting negative 4. So this is not the ideal way of simplifying this expression or equation. So please, we should all bear in mind and then stick to the right thing. So it's either you group them into two inside a bracket, so y squared minus y in a bracket, then also do same for negative 4y plus 4 in also another bracket, and between these two brackets the operational sign between them should be plus, or you can also choose to write it this way: y squared minus y minus out, which is this minus sign, bracket open, 4y minus 4 is equal to 0. So if it's done this way, when simplifying it back to this form, you will still get back this equation or expression. So if the negative sign is taken outside, it's going to affect the operational sign that we have inside our bracket. So let's simplify and attest to the fact. Y squared minus y minus 4y minus minus, which is plus 4 is equal to 0. So doing it this way, we have y squared. Let's compare. Now compare this to this. So we have y squared minus y minus 4y minus 4y plus 4 equals to 0. So when grouping, make sure when or which operational sign to change. So if you want to group it as how you were given from the equation this way, then group them into two, and between the two brackets include plus. If you also want to factor out the negative sign, then if the negative sign is factored out, it should also affect the sign inside the bracket. Let's move on. Okay, so we are going to factor the common thing now. We have y squared minus y, and the common expression here is y. So y is taken out, multiplying y minus 1 plus, so the common thing here to single out is negative 4. So here I'm taking or factoring negative 4 out in order to suit this factor. Y minus 1 equals 0. Y minus 1 minus 4 out, y minus 1 equals 0. So let's go back and check our equation. We have y out, y minus 1 minus 4, y minus 1 equals 0. Okay, so at this juncture we have y minus 1 repeating itself here, y minus 1, and we have y minus 4, which is this together with this, y minus 4 as one factor, and since y minus 1 repeats itself, 1 is chosen, minus 1 equals to 0. So we have our factors, and we are moving on to find, or in finding our zeros. Now we equate each factor to 0 and then resolve. Now our value y is equal to 4. Similar to this, y minus 1 is equal to 0, and y gives us 1. We are not done. We've resolved or calculated for the value of y, but you should bear in mind that from the question, y wasn't part of the question. We introduced y. So this was the original question. This was the original question, and then we changed this question to suit a similar index form, which was 2x, and that 2x was set to the variable y. So we said y should be equal to 2x. Now that we've gotten the value y, we are going to equate it to 2x. So we said let y be equal to 2 to the power x. Now we have y to be 4. So anywhere we see y, we are going to now replace with 2x. Now we have 2x, which is this y. Now this y is equal to 4. So at this point, we change the expression to have a similar base, and the smaller base here is 2. So we will change 4 to also have a base of 2, and 2 repeating itself 2 times gives us 4. So we have 2 as 1, so we are picking 1, and then how many 2's? We have twice of it. And if the bases are the same, the exponents are equated. So we have x to be 2. Let's move on in resolving for this y. So when y is equal to 1, what is it saying? When y is equal to 1, y is equal to 1, so we would let, so from our onset, we said we should let y be equal to 2 to the power x. Now we have 2 to the power x equals 1. And from the properties, which says that any number raised to the power 0 is 1. So meaning, now finding or in search of a similar base or a base of 2, we know 2 to the power 0 is also 1. Now we replace this 1 to this index form. We have 2 to the power x equals 2 to the power 0. And if the bases are the same, the exponents are equated. We have x to the power 0. So from our question, we have two values of x as 2, and then x as 2, and x as 0. So we conclude, hence x is equal to 0 or x is equal to 2. So these are the solution sets of our equation. These are our solution sets of our equation. These are our solution sets. Of our equation, 2 to the power 2x minus 5 multiplying 2 to the power x plus 4 equals to 0. So when this kind of equation is given, then after going through all these procedure, you would now ascertain or get to know that this question leads us to a quadratic equation and is now dealt with. So I'll be giving out numerous examples or questions to try your hands on. Now we move on to the last equation, and our last equation or type. We move on to the last type of equation under indices, which is simultaneous equations. Okay, so with the simultaneous equations, we should know what simultaneous depicts. So simultaneous means doing two things at the same time. Now, here we could be given a linear equation and then a quadratic equation to resolve. We could be given a linear equation or two linear equations to resolve. An example under this simultaneous equation is, so with this first or with the first equation, this equation is in a linear form. Equation is in a linear form, and the second equation is in an exponential form. So we are going to resolve this by finding the value of x and y. So we are going to do this or solve this equation at the same time. So this is what simultaneous means, doing two things at the same time. Now let's delve quickly right into this. So with our first equation, x plus 6y equals 3 and 2 raised to the power x plus y equals 1 on 4. Now we have our first equation, x plus 6y equals 3, and then we have this the first equation as linear equation, the second one is as an exponential equation. And from the exponential equation, anytime you come across this, a x plus y equals a, let's say 2. If the bases are the same, the powers or index is equated. So now we'll be getting x plus y plus equals 2. So we are going to resolve this exponential into its linear form. Now 2x plus y equals 1 on 4. The right hand side of our equation, which is 1 on 4, is equation, which is 1 on 4, is a fraction and could be written in a negative index form. So anytime we have 1 on a, is written as a to the power negative 1. So we are going to write this in a negative index form. Now we have 2 raised to the power x plus y equals 4 raised to the power negative 1. And writing this in a similar base, 4 is the repetition of 2 times 2. So we have 2 repeating itself twice. We have 2 repeating itself twice to the power negative 1. And this is written as 2 raised to the power x plus y equals 2 raised to the power negative 2. And if the bases are the same, the exponents are equated. If the bases are the same, so we have 2, I have 2. Now the exponent, x plus y equals negative 2. And this is the linear form to this exponential. So I'm going to write this linear in place of this. X plus y equals negative 2. Now we move on to solve. So with simultaneous equation, we have 3 ways or kinds of doing this. So this equation x plus and then x plus y equals -2. These two equations can be solved in three ways. So the first one, this can be solved using the elimination. So we have three ways of solving these two equations. Now we have the elimination method. We have the substitution, and then we have the graphical method. We would stick with these two. Methods, either elimination or substitution. So here we are going to use the elimination to solve this, and then at the same time use substitution. So using elimination, to eliminate means to get rid of or do away. So we are going to choose one variable to do away for the first time, and for this equation we are going to eliminate x because x has a coefficient of 1 for the first equation. The second equation also has a coefficient of 1. So to eliminate this, we introduce an operation x plus 6y So to eliminate this, I'm using the negative or the minus sign to get rid of x. Now x minus x gives us 0 plus 6y minus y gives us 5y equals 3 minus 2 also gives us, so 3 plus 2, 3 minus 2 is the same thing as 3 plus 2, which is equal to 5. I have 5. Now we have 5y equals 5 from this point, and by finding y we divide through by 5. Five into itself 1, to itself 5 to itself 1, to itself 1. So y is equal to 1. Now we've gotten our y value. And it's going to help us find our x value. So if y is equal to 1, we are going to put this into any of the equations, either the first equation or the second equation. So x plus 6y is equal to 3. So this is our first equation. And then x plus y is equal to -2, our second equation. X plus y equals -2, second equation. So we are going to put y equals 1 into any of the equations. So into equation 2. It's either 1 or 2. So let me do 1. Now we have x plus, so y is kept here, 6 by 1, which is our y, equals 3. x is equal to plus 6 is equal to 3, and now we want our x value, so x is equal to 3 minus 6, x is equal to negative 3. So now we have our x value to be equal to negative 3 when y was kept into the first equation. Now let's put y into the second equation and ascertain whether we will be getting the same thing as negative 3. So we have x plus y was given as 1 equals negative 2. So this is putting or keeping y inside the second equation. X is equal to negative 2 minus 1. So you see, when y was kept inside the second equation, we are still getting negative 3. So any of the two equation holds. Is either y is kept inside the first equation or the second equation, you will still be getting back the same answer. So now we conclude. Therefore, our value x is equal to negative 3 and y is also equal to 1. So these are our unknowns, our unknown variable for x and y. X equals negative 3, y is equal to 1. So if you want to find out whether what you did was on track or what you did was on track, if you want to find out whether you are correct, now put in these values of x and y back into the equation to find out. So we had x to be negative 3y to be 1. So we have x, which is neg 3 here, plus 6, and then our y was also 1. Negative 3 plus 6 is giving us 3, which is the result. So means these values of x and y satisfies the given equation. So similar to this, we have 2 raised to the power, x was given as negative 3, y was also given as 1, is equal to 1 and 4. 2 raised to the power negative 3 plus 1 gives us negative 2, and this is equal to 1 and 4. So this is also telling us that our value x and y are correct, but the method used in finding these x and y was the elimination method. Now we are moving on to finding these values x and y using the substitution method. Okay, so to substitute means to take out one of the variables. So here we are going to take out or equate one of the variable, and from these two equations, x could be taken out or could be equated to, y could be equated to. So let's equate our first equation to x. Now we have x equals 3, negative 6 is taken to this side, minus 6y. Now we've made x the subject from the first equation. So after doing this, x is kept inside, so we put x, which is equal to 3 minus 6y into equation 2. X equals 3 minus 6y into equation 2. We have to put, so our equation 2 was also y, x plus y equals negative 2. X plus y equals negative 2. So anywhere x is seen, is replaced with y, 3 minus 6y. We have 3 minus 6y as our x, plus y equals negative 2. So at this point, we group like terms. Now we have negative 6y plus y equals neg 2 minus 3. Negative 6y plus y gives us negative 5y. Negative 2, negative 3 gives us negative 5. Now we make y the subject by dividing through by negative 5. Negative 5 into itself 1 into negative 5 1. Negative 5 into itself 1 into itself 1. Now our y is equal to 1. We put in so put y equals 1 into any of the equations. So either 1 or 2. So y is kept in any of the equations to find x. So either 1 or 2, anything holds into equation 2. So I have equation 2 over here. So let me put it in. Now I have x plus y minus 2 as my equation 2. So I have x plus y, which is 1, equals negative 2. And x is equal to negative 2, negative 1. X is equal to negative 2, negative 1, giving us negative 3. So our value for x and y. So therefore, x is equal to negative 3, comma, y is also equal to 1. So we have x to be negative 3, y to be 1. And using any of the method, either elimination or substitution, you should be getting these values of x and y. So if this video was very helpful, please subscribe to my channel, give it a thumbs up, and post me on
Subscribe,
post
like, and
notification
share.
anytime I drop new videos. Thank you for your time. I'm out.